Hello everyone, welcome you all to another video on graph theory. In this video, we will be looking into three more different types of graphs. These are very important in various contexts they are used. So those are complete graph, null graph and regular graph. So what is the difference between them? So complete graph, the name itself suggests complete means every node is connected with every other node. Every node of a graph of that graph is connected with every other node of that graph. Node means vertex. So every vertex is connected with every other vertex in that graph. So here if you observe, the vertex A is connected with vertex B, vertex A is connected with vertex C, vertex A is connected with vertex D. So this is called complete graph. Similarly, B is connected with A, C and D, D is connected with A, C and B and so on. So all the vertex are connected with all the other vertices. Therefore, it is called a complete graph. Here we are introducing another term, degree. Degree of a vertex. So degree of a vertex means the term degree here refers to the total number of vertex it is connected with. For example, here the vertex A is connected with three other vertices. One is B, one is C and D. So we can say the degree of A is 3. Similarly, degree of B, it is connected with A, D and C. So degree of B is 3. So that is the term degree. So it will be used across other graphs also. So degree means the total number of vertices to which a particular vertex is connected. So here we observe that how many vertices are there? There are 4 vertices. So what will be the degree of all the vertex? The degree of all the vertex will be same and it will be n minus 1. So degree of a complete graph is n minus 1. So and the total number of edges that will be required, total edges means A is having 3 edges, B is having 3 edges, like that. If you count the total number of edges, 6 edges are there. So total number of edges is n into n minus 1 by 2. So for example, if you are having a graph having say number of vertex is 10, if there are 10 vertices in a graph, then it will be a complete graph only if every vertex is having degree 10 minus 1, that is 9, and the total edges, if it is a complete graph, the total edges will be 9 into 9 minus 1 divided by 2. That means 36. So there will be 36 total edges. If we sum up all the edges, it will come up to 36 for 10 vertices. So this is all about complete graph. So complete graph means we can consider the network or mobile network. So all the nodes are connected with one another. All the devices are connected with one another. So that can be considered as a complete graph. Let's take another category of graph, that is null graph. It is the total opposite of complete graph. So in case of complete graph, all the nodes are connected or all the vertices are connected with all the other vertex. However, in case of a null graph, no vertex is connected. So A, B, C, D, but there is no any link between them, or there is no path between them, or you can say there is no edge between them. So A, B, C, D, all the nodes are totally isolated. So such a graph is called a null graph. Rarely we find null graphs, but you can just for an analogy we can say that there is a room where 4 friends or 4 or 5 friends are sitting together, sitting there, but they are not talking among one another, or there are 5 people in a particular place, but they are not communicating with one another. So that can be an example of a null graph. So different locations but no connecting paths or connecting links or connecting edges are there. So that is called null graph. If we link it with disconnected graph, which we have already discussed, in case of disconnected graph, the difference between disconnected graph and null graph is that in case of disconnected graph, there will be some components in which there is some connections between the vertex. However, in case of null graph, there is no any such connections. So null graph can be considered similar to disconnected graph, but in null graph there is no any connection between them. So all the vertex becomes a component in itself. So that is all about null graph. And another category is the regular graph. Regular graph is almost like complete graph, because complete graphs are always regular graph, but regular graph may not be a complete graph. So let's look into it. So every vertex has the same degree. If we consider this square is a square and each point is a node or a vertex, so A is having degree, A is connected with two nodes, A is having degree B and C. A is connected with B and C, so it is having degree 2. B is having degree 2, C is having degree 2, D is also having degree 2. So all the vertex are having the same degree and therefore it is called a regular graph. So every vertex has the same degree, that is every vertex is connected with the same number of other vertices. And what the degree is, because A is having same degree, B is having, so all the vertex will be having the same degree. So therefore it is called R regular. R regular. So in this case, R represents the degree of the vertex. So for example, in this case we can call it as 2 regular. Why is it called 2 regular? Because every vertex is having degree 2. Now, if we relate it with complete graph, is it complete? No, it is not complete, because all the nodes should be connected with all the other nodes. However, you observe that A is not connected with D, B is not connected with C. So, although it is a regular graph, it is not a complete graph. Now, take the other case. Is this graph regular graph? Yes. How? Because A has degree 3, B is also having degree 3, C is also having degree 3, D is also having degree 3. So, this complete graph is also a regular graph. Therefore, we can say that every complete graph, if a graph is a complete graph, it will be regular. Complete implies that it will be regular. However, if a graph is regular, we can't say that it will be complete. So a graph which is complete is always regular. However, a graph which is regular may not be a complete graph. So we have to remember this point. With this, we have discussed complete null graph and regular graph. So we will look into different applications of this graphs in subsequent videos. Thank you all. Thank you very much.